This is the first video in Module 3. And in this video, we'll look at exponent rules and review properties of exponents and use them to simplify rational and exponential expressions. Let's get started. All right, we will cover a lot of exponent rules. I'm hoping that you've seen most of these before, but in case you haven't, I will introduce them kind of slowly. And I'm actually going to go from the problems on the right and kind of refer back to and kind of show why these rules work. In letter A, we have 5x to the fifth power times negative 3x squared. Well, what does it mean to have x to the fifth power? That means x times itself 5 times. So I have 5 times x times itself 5 times, times negative 3 times x squared is x times x. Okay, now multiplication is commutative, which means the order doesn't matter, and I can rearrange the order as I want. Okay, so I have 5 times negative 3 is negative 15. And then I have x times itself how many times? Well, I have 5 plus 2 more is x to the 7th power. Okay, and this is what I get. Okay, and what that's referring to we call the product rule. If you're multiplying two numbers with the same base of the exponent, you can add the exponent. So x to the a times a to the y, a to the x times a to the y is a to the x plus y. Okay, you can add those together because you have x number of a's and y number of a's, and so all together you have x plus y number of a's. All right, in letter B, we have 3x to the fifth over 2x to the fourth. Now notice we have 2x in the parentheses, and so the thing being raised to the fourth power is not just the x, it's the whole 2x. So I have 2x times 2x times 2x times 2x. Okay, so I have 2 times 2 times 2 times 2. And 2 times 2 is 4, times 2 is 8, times 2 is 16, so I get 16. And then I have 4 x's, so it's x to the fourth power. Now I want to kind of keep going with this to write it in the form of kx to the n. That's my end goal. But I'll also do it in a way that shows the quotient rule. So in the numerator, I have 3x to the fifth, and x to the fifth means x times itself 5 times, divided by 16x to the fourth, but x to the fourth means x times itself 4 times. And so from here, I can start to cancel off x's, the same number on top and bottom. How many am I canceling off? I'm canceling off 4 of them. So if I take away 4, cancel 4 of the x's from the 5's, how many are left? Well, I have 1 that's left. I get 3 over 16 times x to the first power. Okay, and that's the quotient rule. Okay, if you have a to the x divided by a to the y, then you can subtract a minus y, or top minus bottom. I could have done, over here, x to the fifth divided by x to the fourth. I could have done 5 minus 4 is 1 and gotten the one that's right here. Okay, that's the quotient rule. Okay, letter C actually has 2 big ideas in it. The first one I want to talk about is this negative third power. Okay, what does it mean to have a negative exponent? It's probably a new thing for you if you've never had negative exponent. So if you go over here, okay, so it's pretty easy for us to notice that going this direction, I'm multiplying by 2, multiplying by 2, multiplying by 2. Nothing really fancy happens there. But if I take it backwards, I could get there by dividing by 2, dividing by 2, dividing by 2, right? So I can keep the pattern going, right? So if I do 2 divided by 2, I get 1. And if I keep this pattern going, minus 1, minus 1, minus 1, if I keep that pattern going back, then I have 0, which means that 2 to the 0th power is 1. And if I keep this going back, I have negative 1, negative 2, and negative 3. And so, again, on this right side, I'm dividing by 2. So 1 divided by 2, or 2 to the negative first power, is 1/2. 1 divided by 2 is 1/2. 1/2 divided by 2 is 1/4. That's 2 to the negative second power. And then 2 to the negative third power is half of 1/4, which is 1/8. Okay, and notice that I have right here that I have 2 to the 8th is equal to 1 over 8, which is 2 to the 8th, which equals 1 over 2 to the third power. Is that you can change the sign of the exponent by changing which side of the division bar we're on. So using that rule about negative exponents, and that's our negative exponent rule right here, using that rule about negative exponents, I can take this down here, which is x squared being raised to the negative third power, and bring that to the numerator, switching which side of the division bar it's on, and change the sign of the exponent. And I would get 3x squared to the positive third power. Okay, that's using negative exponents. Okay, now I'm going to go over and talk about what's called the power rule, because I have an exponent being raised to an exponent. The power rule. I have an exponent being raised to an exponent, and so if I think about 3 is just hanging out. X squared to the third power is x squared times itself 3 times. I have x squared times x squared times x squared. And then using the product rule, I can add 2 plus 2 plus 2 is 6, and I get 3x to the 6th power. Okay? Now, using the power rule, I could have simply done 2 times 3 is 6 and been done without skipping that middle step. Okay? That's the power rule. Next, we'll do letter D, and we will kind of use the rules we've already been studying. So first, we have the product rule in the numerator. Okay, I have the same base, so negative 3 plus 4 is 1, and so I get x to the first power. X to the 8th is still there. And then I have the quotient rule. Again, it's top minus bottom, or numerator minus denominator. 1 minus 8 is negative 7, and so I have x to the negative 7th power. Okay, now just so you know, you could also write this as 1 over x to the 7th power, but in the directions, they've asked to write it as kx to the n, and so I'd prefer in this problem to write it as x to the negative 7th power. All right, in letter E, there's one other idea we've not talked about yet, and that is because I have a fraction to an exponent. I have 3 over x to the negative 22nd power to the third power. Okay, and similar to the power rule is I can raise each of those pieces to that same power. Okay, so I get 3 to the negative third power divided by x to the negative second to the negative third power. I can multiply together negative 22 and negative 3 and get a positive 66. Okay? All right. Now, again, I'm trying to get into the kx to the n power, and so I'm going to bring this x to the 66 power into the numerator by changing the sign of the exponent, and also making this kind of by itself. So I have 1 over, bringing this down, kind of switching them. I have 3 to the third power times x to the positive 66th power. Okay, bringing the 3 down, changing the sign of that exponent, bringing x up and changing that exponent. Oh, it's negative, sorry. Next, okay. And then 3 to the third power is 3 times 3, which is 9, times 3, which is 27. I get 1 over 27 x to the negative 66th power. So there's a lot of of rules here. I'm hoping, again, you've seen these before. This isn't brand new for many of you, but that's a lot there. Okay, there's one idea I want to hit still in this video, and that is the idea of fractional exponents. Okay, to introduce fractional exponents, let me show you two things that can happen. We know that the square root of x, and then if I square that number, the square root and the square cancel each other out, and I just get x. Okay, but we've also learned this exponent rule, this power rule, where you have an exponent to an exponent, and I could also write this as x to the 1/2 squared. And using the power rule, I'd multiply 1/2 times 2 and get 1, and so I get x here. And if I raise two things to the same power and get the same number, that means that these things inside the parentheses must be the same. Okay, so a square root and the 1/2 power are the same thing. Okay, so that gives rise to the fact that we can write exponents with fractions in them. Okay, and that the denominator becomes our root. Okay, now maybe you're kind of new with the idea of roots. Maybe you've seen a cube root before. You've definitely seen square roots before. Okay, in letter F, we have the root on the denominator, so this is actually the 6th root of 2. And just so you know what that means, that is approximately 1.1222462. Okay, it's the number that if I raise it to the 6th power, I'd get 2. That's what that means, 6th power. Okay. But in general, if you have a numerator is the power and the denominator is your root. So in letter G, it's the 3rd root of 2 to the 5th. Okay, so again, the numerator becomes your power and your denominator becomes your root. So this is the square root or the 2nd root of 10n to the 3rd power. Okay, but just so you know, we typically don't write the 2 on the square root. That's kind of implied because you've been doing this already, that if you see that sign, you know it's a square root, which is a 2nd root. Okay, letter I has a bit more to it. There's a negative exponent. So we've actually gone quite a bit in this video. We've gone from whole number exponents to negative, and now to fractions, and now to negative fractions. So the negative exponent means I can write it as 1 over 5x to the positive 5/4 by changing the sign of the exponent by bringing it below the division bar. And then I can write it as power over root. I have the 4th root of 5x to the 5th power. Okay? And in letter J, I have 10 to the power of, let's see here, there's no root written there, so I'm going to assume it's a 2nd root. Power over root. It's 10 to the 3/2 power. Letter K is similar. I have 2 to the power over root 5/4 power. Okay. In letter L, I'm going to bring this to the other side of the division bar by writing the square root of 3k to the negative 5th power. And then knowing that it's a square root because there's no number here, I'll write it as power over root, and I get 3k to the negative 5/2 power. So that's the idea of fractional exponents. Again, probably a new idea for you. All right, this video was about exponent rules. We looked at properties of exponents and used them to simplify rational and exponential expressions. We also introduced negative exponents and fractional exponents. Thank you so much for watching.